All right, so cool. I want to talk to you. So there's actually a little bit of an adjustment to my talk. The thing is, AI moves, like 1 year per month, and it's kind of crazy times that we're living in. So between the time I proposed the talk and between the time that I actually developed the talk, where it made sense, roast has come a long way. And actually, it's, I think, even more interesting than just reviewing your code for reasons that we're going to get into. So this talk is really about different ways to do workflow in the age of AI. And most of us, in one way or another, have to do workflows from time to time. The act of reviewing code in itself is a workflow. A lot of the things that we do from day to day are essentially manual workflows in one way or another. A lot of things that we end up doing with agents are in essence workflows. We may not think about it that way, but once you've written a prompt and given it to an AI agent and it has a list of more than one thing that you want it to do, you've essentially created a workflow. And there are different ways to do workflows in this age of AI that we're living on. You could just do a prompt and plop it into a program. Use Ruby LLM or my own library called Ray if you're doing Ruby, or put it into some other runtime for AI. But for those of you that have done that with any sort of regularity, you know that this can be very, very hard to maintain. So there's also the other extreme, which is agentic workflows and agentic tools, and that's where you have one or more, let's say, independently acting agents that you give instructions to and you let them do things. And agents are really good, but in the interest of time, I'm not going to delve into what you can do with agents. Instead, I'm going to talk to you about structured workflows. And the reason that I want to talk to you about this is because agents, and by agents, I'm using agents in the big sense, not just like collections of agents doing work, but also if you give a big prompt, to a state-of-the-art model and say, hey, do this step 1, 2, 3. This is the reason that they suck at doing workflows. If you look at this table, even if you assume a very, very conservative error rate, and given that AIs are non-deterministic, 0.1% is actually quite conservative. After 20 turns, you're only at 98% success, and at 50 turns, you're at 95. Now, if we go with more realistic kind of error rates, you see that the resulting effectiveness of agentic workflows plummets, in some cases getting down below 50% or even close to 0. So even though workflows might seem, in a sense, to be a boring topic, there are cases where boring is actually good. I figured this out dating back to February 2025. In my role as principal engineer at Shopify, I was leading some of the strategic internal work on tools involving AI to enhance our developer experience internally. And one of the first things that I was given, I worked on with a fellow Shopifyer, Shopify named Paulo Arruda. He's also the author of Claude Storm, by the way, and an awesome Rubyist. So Paulo and I set to work on creating a script in Ruby that used my library Ray, which stands for Ruby AI extensions. And we wrote a program to critique Ruby code. And during that time, we wanted to have a little fun while we were pair programming. So at one point, instead of just doing a serious critique of the code we were looking at, I said, hey, why don't you roast it in the way that a comedian would roast it? And that's where the name comes from. So it's just kind of a funny thing. The funny roasting was in there as an Easter egg for a little while and then eventually came out, but the name stuck because it was catchy. After doing some critique of our Ruby code, they said, hey, actually scratch that. What we really want you to do is to generate Ruby code and Rails code and to generate tests. So at that point, we had duplication. We had another script that did essentially the same thing, and I said, you know what? I think this is going to become a theme. Let's extract the common parts into a framework. And roast at that point pivoted and became more than just a grading tool. So I've been talking about roast. What is roast? It's a Ruby gem. You can install it the way you would typically install a Ruby gem, and you get a roast command line command. There's the URL, it's Shopify roast. The style of roast is convention over configuration. It is deeply inspired by Rails. And it allows you to mix non-deterministic, there's actually a little bug in that slide. I would say non-deterministic, meaning just regular code, with non-deterministic AI, I got a little confused there, with deterministic steps, meaning sometimes you talk to the AI and you do some language processing with an LLM, sometimes you run bash scripts or Ruby code or whatever the case may be. The aim is for it to be easy to understand, easy to be able to share and maintain the scripts, the roast workflows, which are written in YAML. The idea is for it to be composable and a lot more things to do. So during this talk, what I aim to do, I'm not going to do demos because watching workflows run is pretty boring, actually. But I'm going to try to scrape the surface of everything that it can do. Because this caught on like wildfire inside of Shopify, and soon we had a dozen, and then we had more teams internally across the organization. We have thousands of engineers at Shopify. So there were many, many teams using roast, and we started building a team. And in fact, that was what that last slide was. It's eventually the team that was working on roast. So it solves a big problem. The big problem that it solved, and the reason that it got quick adoption at Shopify, is that there was an ongoing explosion of AI scripts in many, many different languages using many frameworks. It was considered okay because it's kind of like a Cambrian explosion where you want to see what survives, right? Like there was so much utility being created. However, it was becoming, I think, a maintenance nightmare in some regards, and also from my position as principal engineer, I was looking at it and I was saying, there's a lot of wasted effort here. There's a lot of duplication. There's a lot of lessons being learned over and over again. Let me give you a quick, first look at what a workflow looks like. It's a YAML file. You name your workflow and give it some descriptions, but fundamentally you have a series of steps. Roast can operate on a single file, or it can operate on a directory, or a collection of files, or nothing at all. The point is to do a list of steps, and those steps make it as easy as possible to describe what you're trying to do quickly. And it has some syntax sugar to be able to do things quickly. So in this case, for this example, which is one of the examples in the code base, the first step is to run a bash command, and that's designated by the $sign in the parentheses. And then the following three steps are just prompts. Since they're short prompts in this case, they can just be inlined. They don't have to be inlined. And in fact, the convention over configuration part that I mentioned before is that if you put an identifier, it will actually look in a well-known place for those prompts. But in this case, what's going to happen here is that this workflow represents a single conversation with the LLM, a multi-turn conversation that builds up a context and ends up giving you a result at the end of this execution. So in that case, it's going to read these orders, who knows how long they are in this case, and it's going to say, where are most of my customers from? The AI will answer that. It'll go into the context. What is my most popular product? That will get answered as well, and that will go into the context. And then summarize the insights from the report. And that final step has access to the context. It has access to the answers that happened before, and then it will spit out the result. Some of the things that really sets roast apart, and actually I looked during the course of preparing this talk, and I didn't really find anything else like roast exactly, especially not in Ruby. I would, if any of you know of something like roast in Ruby, please let me know after the talk. But key features, I've already mentioned some of the things, the first two bullet points, but it does have built-in tools that can be accessed as tool functions within the conversation that you're having with the AI. It also features parallel step execution. I'll show you an example of that in a second. It has caching and replay built in, and I'll also mention that later in the talk, but essentially while you're developing multi-step AI workflows, given that the AI is generally slow to respond for bigger things, you don't want to sit there and wait for the same step to be generated over and over again. Raise your hand if you've done something like that where you've sat and just kind of like gotten really frustrated. Yeah. I assumed a lot of hands would go up and a lot of hands did go up. So you can also write custom steps in Ruby, and there's extensive instrumentation. It actually leverages the notifications module of Rails to be able to fire off events as steps are happening so you can tie into it. In terms of the use cases, what's it good for? Well, code evaluation was the first thing we wrote it for, so I think it's pretty good for that sort of thing. It's also good for code generation, for log analysis, data pipelines, web scraping. I'm mentioning things that I saw that teams at Shopify were actually using roast for, but basically anything that you do a workflow for. And in fact, one of the key things I want you to take away from this talk is that you can actually use roast, and you should use roast, for scripts that maybe only have a sprinkling of AI. The fact that you can just have a series of, let's say, bash commands, given everything else that roast gives you, plus the ability to sprinkle in AI, I think actually makes it a compelling tool. So in terms of getting started, install it as a gem. Unfortunately, I pulled down the latest release, and roast init is currently broken, but normally you would run roast init. This is early software. It's at 0.4. That's a good thing, I'm going to say, because it is very valuable considering where it's at, but there's still a lot of room for improvement and contribution from the community. And then finally, it does have a bunch of command line features. I didn't want to bog this slide down with putting them all, but the main one is to roast execute, and you point it at a workflow file. So the simplest possible workflow would just have one step. In that case, say hello. If you run this, this may happen to you because it's not well documented that you have to do it. It's going to give you an error, and it's going to say, hey, it requires Ray to be properly initialized. Basically, you need to create an initializer directory wherever you have your whatever project you're using your workflows in. So I added that, ran it again, and this is what it looks like when you run a workflow. So it starts the workflow, it tells you which workflow file it's running, what options it's using. In this case, it'll tell you it's running a target list workflow because you didn't pass it a series of files or a directory to work on. And it's going to execute it, consumed 18 tokens. The output was saved to a file, and also there's a SQLite database that's created in the .roast directory that starts tracking those executions. In this case, it said, hello, how can I assist you today? That was the output at the end. Here's an idea of basically what the sessions look like, the different commands that you can get. You see that after running this, I ran sessions, and I have one session in this particular directory. Let's do a more complex example. I wanted to show you a more complex example, and this is what it looks like to grade a test. So in this workflow, and I don't think I have a pointer, do I? Yes, maybe I do. No, that's it. I'll just point at it. So in this example, we're going to read dependencies, then we're going to run coverage, and then the fact that this array is nested means that these will run in parallel. So the steps that we're going to execute in parallel is to analyze coverage, verify the test helpers that are used by this test, verify the mocks and stubs, and sorry, I'm in the way. And then finally, once that little block finishes and it comes back to the main context, it'll generate some grades, calculate them, format the results, and generate recommendations. These are just symbols. They're pointing to subdirectories of your workflow folder, and inside of those, you have a series of prompts. This happens to be the top level prompt, which equates to your system prompt for the conversation. It's named the same as your YML file, so it just looks for an MD file by convention. In this case, since we're grading, it says, as a senior software engineer and testing expert, evaluate the quality of this test based on the guidelines. You have ERB here, and you have context variables. In this case, we're reading the file. This is not a targetless workflow. This particular workflow is pointed at a specific file that's available as file, and we read it into the system directive. And then just showing that same workflow configuration that I showed before, but zooming into the first step, or rather to the second step there, which is run coverage. If I showed you read dependencies, it would just be a prompt that says, go in and use the tools that you have been provided, which are search and read, etc., and look for the dependencies of this test. The second step here is to run coverage. Running coverage, given that we were feeding this not only Ruby but also TypeScript files, was not trivial. So we wrote a Ruby class, which is the implementation of this step, just to show you that you can do custom steps with custom code. And in this case, it's looking for the extension, and if I showed you the rest of the code, you would see where it basically puts together whether to run a mini test or to run some other executable. So when we run that, it generates a whole bunch of output. I wasn't going to show the whole thing here, but essentially this is what it looks like after it finished reading dependencies. So you'll note that there is tool calling going on. So there's a bit of agentic behavior, if you will, if you want to think about it in that way, in the sense that that prompt said, hey, I want you to grade this test, but I don't want you to grade this test in a vacuum. That would be like the naive approach, right? You just generate a prompt, you put in the source code of the test, and you say, hey, grade this test. How can I grade the test unless I read the dependencies? Right? So that's the first thing that happened there. In this case, this is on a pet project called Created, so I passed it the user spec that's at the very top as a target, and it decided to look for user RB, invitation RB, organization RB, the dependencies of user, essentially. I've shown you two kinds of steps so far, which are commands that shell out to bash, and also prompts, and I guess you could consider custom Ruby steps a third kind of step. There's also another kind of step, which is an agent step. So once we got into generating code, it was important to give ourselves the power of not reinventing coding agents, in this case, Claude Code. So the fast way to invoke a coding agent is just to put a caret before your step. And in that case, it'll know, don't pass this prompt to the main context that's executing, pass it to a coding agent. And it uses the command line mode of Claude Code, or in the future, other coding agents to pass in instructions, and then let that coding agent go hog wild with whatever it is you told it to do. And when it's finished, come back to the main workflow execution. In terms of features, I can't stress enough that even though it's early in its versions, because we had so many teams using Roast internally at Shopify, we ended up getting a lot of feature requests right away. One of the first things that we were asked is like, hey, can you put in essentially some programming constructs, so looping and conditionals, etc. So this is what it looks like to repeat. And in order to be able to, in a YAML file, determine the parameters to the conditionals and to the looping, we used this double curly brace syntax to do interpolation of Ruby code. So in this case, is checking until a counter gets to a certain amount, and it'll continue doing those steps. There's also each syntax. Very briefly, like I said, I'm just kind of scraping the surface to give you an idea of what's possible. There's conditionals as well. You can actually use almost anything as the parameters. You can interpolate Ruby code. You can use bash commands, which is in the $signs. You can even use prompts themselves, which is something I had a hard time kind of illustrating on a slide. You would kind of have to see it in action. But basically, if the argument to your conditional is itself a prompt, Roast is smart enough to take the results of that prompt and coerce it into a type that's compatible with the argument that you were passing to the conditional. In the case of a conditional, it would be a Boolean argument. If you're passing it, something that required text or a number, it will coerce it to text or a number, or you could explicitly cast it. Here's an example of how an initial step sets up data that's used by that conditional later on. So that first prompt, which is detect language, tells the LLM, based on the file extension and content, determine the primary programming language of this file. This is almost a trivial example, but there's lots of things that work like this. Basically, this is a categorizer of sorts, right? But if you passed it a rake file, it would do the right thing. If you passed it a gem file, etc. And in this case, it's going to return the language in lowercase, and then that case statement there on the third line of the workflow says case workflow output detect language, and that's what drives the case expression. At some point, the reason that you see dot notation there is because we said, oh, it's just such a pain to have to write out the hash notation and everything, so we just went ahead and implemented dot notation that will navigate hashes to make sure that that workflow file stays really nice and readable. I mentioned before that there's built-in tools. This is the list of built-in tools that Roast provides out of the box. You have an API for creating your own tools, and I'll mention MCP in a second, but these are the built-in tools. You can read file, you can write a file, you can update more than one file at a time. You can also grep, which, if I'm not mistaken, implements ripgrep for performance reasons. You can search, execute shell commands, or bash with like full error handling, and of course the coding agent. Because everything's about MCP, and for good reasons, we did implement MCP support, and it works with both HTTP-hosted MCP servers and also standard I/O-based MCP servers. So you can drop these right into your workflow configuration and say, use an MCP tool. And right away, we noticed, okay, well, when we do that, we don't actually want all of the functions or resources provided by MCP, so there's also capabilities for saying, I want this function and not another function. And you might think that I was just mentioning advanced features, but no, there's more. There's the instrumentation that I mentioned before and the parallelism. One of my favorites is session replay. As I mentioned a little earlier in the talk, it is very, very time-consuming at times, especially when you're working on longer workflows, to have to sit there and go through the earlier steps and just wait for those earlier steps to execute. So we took the time to implement the ability to, when you execute a workflow, say resume, and it'll just do the last one, and you can tell it what step to resume from, or to actually provide a timestamp that corresponds to a session, and optionally a step name to replay a previous workflow right from where you left off. This is very, very important for developing workflows. Similarly, also mostly useful in development. Some functions take a long time to execute. So if you're calling those functions, you can turn on function caching, which means that identical inputs will produce identical outputs, and those are cached. Again, saves time and money. As we were going along, and keep in mind that the Shopify code base is pretty large, we ended up running into situations where we would overflow our context limits, meaning that that one single conversation that we're having with the LLM as we execute the workflow gets so big that it actually overflows the limit of 128,000 or 250 or even 1 million, if you're using Gemini. So Roast also has context management features that let you specify what you want to happen in that case? Do you want it to fail? Do you want to do some sort of smart compaction? Do you want to do compaction but retain steps? So when you're having a conversation with Claude Code and you do compact, it just compacts all of the rounds of the conversation that you had with it. But when you're doing a workflow, you can't just blindly do a compact because there's dependencies from one step to another, right? So this gives you the ability to, say, retain steps as opposed to compacting. I kind of alluded to at the beginning of the talk, but I didn't find any competition to roast in the Ruby space, but there are certainly ways to do workflows if you step outside of the Ruby community. You could, of course, hand code your workflows, but outside of Ruby, there's, I think you call it Nathan, I don't know, or N8N, which is a visual builder. You can self-host that yourself. It's an open source project, or you can use it in the cloud, which I think is what most people do. There's also a newer one that looks pretty cool called Trigger Dev, which is a pretty awesome, features a pretty awesome fundamental technology in the sense that it's able to do kind of continuations writ large, in the sense that it can capture the state of a binary execution and stop it, and then put it away, and then pick it up at some point later. So for workflows that execute over the course of a lot of time, because maybe they're waiting for user input or for certain real-world events to happen, that's a viable solution. And then finally, there's these platforms like Zapier and Make that let you integrate a lot of different things and are essentially workflow tools. And of course, they have been adding AI tooling all along, right? The road ahead is pretty exciting for Roast. I think there's lots of opportunity for community contributions. There's a lot more needed in terms of examples and documentation. I kind of wanted to write a book on Roast, and then that got interrupted. I don't know why we just lost the signal, but okay, there it goes. And actually, in the latest release, they blew away all the examples. So I don't know what's up with that. I got to talk to Sam, who's currently the leader of that at Shopify. But a lot more examples and documentation needed. Also, I think there's a lot of room to do graphical user interfaces, like the ability to maybe do N8N style node, graphical representations of your workflow where you drag things around and kind of wire them together. Dashboards to see the status of the execution of your workflows, I think would be really cool. And then finally, how do you integrate these things easily into your CI and CD pipelines? It is fairly straightforward because it's just a gem, but it would be nice to kind of have well-defined integrations. Also, the ability to add additional coding agents. Right now, as far as I know, we only support Claude Code. It would be really nice to support, for instance, Gemini and Codex and better tools. Including patterns is the final step. I think that there are lots of opportunities to take some of the, let's say, well-known uses of tools like this and kind of package them up as subgems that work with Roast, either as plugins or just things that you can very easily bolt on. So now it's time for you to roast me.